Good afternoon to all of you. Welcome you guys. Welcome you all. How you are doing, everybody? How you are doing, everybody? कैसे हो सभी लोग? Right. I hope all of you are doing great. So first of all, do check whether is the audio video is clear to everybody. Audio video check करके comment करके बोलिए ना भैया. Is the audio video is clear to everybody? Yes. चलिए आज का सेशन हम शुरू करेंगे. सबसे पहले so we are great announcement from Unacademy team से. So you can get it as a get 72 hours scholarship challenge. This is for the 2027-28 के लिए. So ये तो बहुत बढ़िया मौका है. So and there is chance to get up 90% of scholarship. So this is exam is on the 1, 2, 3 sessions are there. Now we starting a new batches. We are starting. You can see now from the 28th April से नया batch शुरू हुआ, and the EDC and general aptitude has been started. You can find the top educators team एक साथ आपको मिलेगा. You can see now here. So EDC and general aptitude शुरू हो गया. And this Unacademy, so GATE 2026 का rankers you can see now. These are the rank. The GATE 2026 का rankers you can find these are from only EC and electrical से. These are ESC 2025 का rankers. Have a look at now how many rankers are there. And another good news is the Unacademy AI tool. The 3 modes of operations are there. One is the voice mode, quiz mode, smart summaries. With this, you can able to utilize according to requirement. You can use them. Test series is also available. Unacademy will offer the 2 subscriptions. So one is a plus subscription, the other one is a iconic. And plus में आपको क्या मिलेगा? टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट्स, evaluate टेस्ट सीरीज एंड स्ट्रक्चर्ड कोर्सेस, लाइव क्विज, अनलिमिटेड एक्सेस. आइकॉनिक में क्या चीज एक्स्ट्रा मिलेगा? पर्सनल कोच मिलेगा, फिजिकल नोट्स मिलेगा एंड आस्क ए डाउट फीचर्स. राइट. So चलो आज का सेशन हम शुरू करेंगे. You can start your serious preparation with Unacademy to achieve your dream goals. We are there to provide you the best guidance for you. ठीक है. चलिए आज का सेशन हम शुरू करेंगे. So let's see now. We'll start doing from the basic problems onwards. We'll do. Okay, each and every problem. Yeah, take this problem. At room temperature, that is 27 degrees, the resistance of heating element is 50. The temperature coefficient of a material is given. The temperature of the element when the resistance is 62 ohms is. Right. So you can see now here at room temperature. So this means, as we know, the variation of resistance with the temperature, which is given as R is equal to R naught into 1 plus alpha T. This is the variation of resistance with respect to temperature. At 27 degrees, the resistance is given as when the temperature T is equal to 27 degrees, they given the resistance value. How much given? 50 ohms. And alpha given. The temperature of the element. So what will be the T value? So that resistance at some location given as 62. The resistance becomes 62. Then how much the temperature at that instant they are asking. Right. Tell me now, substitute the values here. So this is given as 60. Initial condition if we substitute now here, so that is 50 equal to R naught into what element of 1 plus alpha into T. T value 27. Next one. So 62 which is equal to R naught into 1 plus alpha into T. If I have taken the ratio between these two, so that is 62 by 50, I have taken the ratio, will come it as 1 plus alpha T by 1 plus alpha into 27. Alpha into 27. And you can substitute these values. And if we cross multiply, so if I cancel it now here, how much will get cancelled? So this is 25s now. Now this is 3 ones. Any other cancellations? I think so, no. Alpha value we know, T value we need to get. So if we cross multiply, so how much will come? So this is 31 plus 27 into 31 alpha, which is equal to 25 plus 25 alpha into T. Yes, we know this alpha value here. So 31, so minus 27. So it will come to be a 6 now. And 6 is equal to, if I take it as a alpha common here. Okay, alpha value will substitute now here. This is 25 into alpha value, how much? 2.4 into 10 power minus 4. And this value better will keep here left side only. So then this is 6 plus, that is 27 into 31 into alpha value 2.4 into 10 power minus 4, and which is equal to 25 into 2.4 into 10 power minus 4 into T. So how much will come here? 31 into 27 into 2.4. So this is into 10 power minus 4 now. And this is plus 6. This value come to be a 6.2 by. So this is 25 into 2.4 into 10 power minus 4 equal to T. Now simplify this thing. How much will come? 6.2 by 25 into 2.4 into 10 power minus 4. So this T value, which is coming to be a 1033. Yes, this is the temperature. Got it, all of you? Same thing. Next one. The resistance of a wire at 0 degrees. At 0 degrees, 100 degrees and T degrees is found to be given as like this. The temperature T in Kelvin they are asking to find. Okay. So the variation of resistance with respect to temperature, which is given as R equal to R naught into 1 plus alpha T. The resistance at 0 degrees given as how much? 10. So 10, that is R naught. So that value given as R naught value given as how much? 10 ohms. Next, at 100 degrees given as a 10.2. That is 10.2. 10.2 equal to 10 into 1 plus 100 into alpha. Right? Yeah, from this we'll get this alpha value. Is it necessary to get alpha? Yes, alpha is required. So this value 10.2 by 10 and which is equal to 1 plus 100 alpha. So that means what I can say 100 alpha, which is equal to this is minus 1. So it will come to be a 0.2 by 10 will come now. That is alpha will come to be a, so we can say 2 into 10 power minus 4. Check it all of you. Now we use the second condition. So we need 10.95, which is equal to R naught is 10 into 1 plus alpha. Alpha value we have 2 into 10 power minus 4 into t value we have to get. So then it is 1 plus 2 into 10 power minus 4 into t, which is equal to 10.95. So that is 2 into 10 power minus 4 into t, yes, by 10 also. So it will come to be 0.95 by 10. So that is t, which is coming to be a 0.95 by, this is 20 into 10 power minus 4. Yeah, simplify, tell me the value. So this is 0.95 by 20 into 10 power minus 4. So this value will come to be how much now? 475 degrees Celsius. And here the thing is, they ask in a Kelvin, they ask in how to convert the temperature into Kelvin. Will add the 273 will be added now. So that means T, which is equal to, so this is 475 plus 273. Then which will be, which is equal to 748 ohms. Formula. So here we see the variation of resistance. The resistance of a material which it changes with the temperature. How the resistance will changes? How the resistance will changes with the temperature? Resistance of a material is not a constant. If I say R naught is a resistance, R naught is a resistance at 0 degrees Celsius. At 0 degrees Celsius, and alpha is the temperature coefficient of resistance. Alpha is a temperature coefficient of resistance. Then the resistance at some other temperature is given as R naught into 1 plus alpha into T. This is the variation of resistance with respect to temperature. This formula we are using here. Okay. Next one. Look at now. A wire of resistance R and radius small r is stretched till its radius becomes R by 2. Till its radius becomes R by 2. If new resistance of the stretched wire is X into R, new resistance is given as X into R, then the value of X is. Okay. So what happens, you see this thing, they given the wire is stretched. So that means R, which is equal to what the formula, that is rho L by A. Here, what is the variable parameter? Radius changes means area changes. So I'm multiplying and dividing with A here. Then it will come to be a, what, tell me now here, rho into area into length is called as a volume now. Volume by A square I can say. So that means what I can say now, R proportional to 1 by A square, and that is R proportional to A means pi R square. That means R square, it will come to be R power 4 now. The resistance, how it will changes? It will changes R power 1 by 4. Okay. Now tell me now here, they has given, what they given in this case? The resistance. Initially the resistance R1 is given as a R, and then we need to get this R2 value we need to get. Initially radius R1 is equal to small r, and R2 equal to what I can say, tell me now, R by 2. Yeah, you tell me now here, R1 by R2, and which is equal to R2 by R1 whole power 4 now. That's why R by R2, which is equal to R by 2 by R whole power 4. That is R by R2 equal to 1 by 2 power 4. That is R2 equal to what we can say, 16. 16 into R. This is the new resistance. Okay. Next. The current in a conductor is expressed as like this. Now the amount of electric charge that flows through a section of conductor during t is equal to 1 second to 2 seconds is, like, given this current I value given as what, tell me now, 3t square plus 4t cube. We need to find the charge we need to get now here. Charge q, which is equal to integral of I into dt. Integral of I into dt. Yeah, you can tell me now here q how much will come here. Integral of, we need to find the charge from t is equal to 1 to 2 seconds. That is 3t square plus 4t cube into dt. Yeah, simplify, get this one. So this is 3 into t cube by 3 plus 4 into t power 4 by 4. And the limits are what, tell me now, 1 to 2. So those will get cancelled, 3 will get cancelled, 4 will get cancelled. Now, so that is given as q, which is equal to 2 cube now here. Will come it as 8 minus 1 plus what, tell me now, 16 minus 1. So how much will come here? This is 7 plus 15. And which is equal to how much now? 22 now? 22 coulombs. Next one. An electric toaster has resistance of 60 ohms at room temperature. The toaster is connected to a 220 volt supply. If the current flowing through it reaches 2.75 amperes, the temperature attained by the toaster is, okay, they given the resistance at the room temperature is given, okay, alpha also given, okay. Next, they ask him to find the temperature, okay. So initially at room temperature, the variation of resistance, which will be given as R equal to R naught into 1 plus alpha into T. Yes, so this is at room 27 degrees, resistance is given as a 60. So 60 equal to R naught, we don't know. R naught, so into what I can say now, 1 plus alpha. Alpha given 2 into 10 power minus 4 into T. T value temperature given as a 27 degrees Celsius. At some other location, they given the voltage given as how much now? 220 volts. And this current is given as how much now? 2.75. Then what will be the resistance now? That is V by I, which is equal to 220 by 2.75. Yeah, tell me how much will come? 220 by 2.75. This is 80. So this is 80 ohms. Now this condition we place now. So 80 equal to, that is R naught into 1 plus alpha 2 into 10 power minus 4 into T value we need to get. And let's simplify now here. Take the ratio between these two equations. So we'll come to be a, so we can say now 80 by 60, and which is equal to 1 plus 2 into 10 power minus 4 into T by, so this is 1 plus, so 27, that is 54. 54 into 10 power minus 4. Now check for cancellations. Now here with 0 cancel. This is 4 and this is 3. Okay. Now tell me now simplification of this thing. So which will be equal to, cross multiply here. This is 4 plus 50. Yes, 50. 4 into 4 into 10 power minus 4 equal to what? Tell me now here. 3 plus 6 into 10 power minus 4 into T. If I bring to here, this side will come to be a 1 equal to what I can say here. 10 power minus 4. No, what we'll do here, we'll simplify this thing. No need to bring this side. So this is 1 plus, so here 54 into 4. Yes, into 10 power minus 4 we have. So this value 0.0216, which is equal to 6 into 10 power minus 4 into T. So plus 1 divided by 6 into 10 power minus 4. So will come to be a T value, which is coming to be a 1702 degrees Celsius. And you can see the nearest option for this one is C now. That could be the nearest option. Okay. Next. The electric current through a wire varies the time as I given as like this. The amount of charge crossed through a section of the wire in 20 seconds they asked him to find. Yeah, they asked him to find this I, which is equal to I naught value given as 20 and beta value given as 3 into T. Now what I will get the charge Q here, integral of I into dt. So let's find out now here, integral in 20 seconds 0 to 20, and which is equal to 20 plus 3t into dt. Yeah, tell me the integration of this one. which is equal to 20t plus what tell me now 3t squared by 2. So limits are what tell me now 0 to 20. And simplify this thing. So how much will come the Q value? 20 into 20 plus 3 by 2 into 20 square means 400. So this value 200 na? So this value 400 plus 600. So how much the charge you tell me now here? 1000 coulombs. Next. A wire of resistance 160 ohms is melted and drawn in a wire of 1/4 of its length. Now the length become 1/4 of the initial length. Then they ask him to find the new resistance series. Here tell me now here the R equal to that is rho L by A. So the length changing, so that means we are multiplying with both side with what tell me now here L से multiply करो. So that is R equal to we can say now rho L square by volume. Volume constant, resistivity also constant. So from this we can say resistance is directly proportional to L square. And so you can tell me now here in this case resistance of the wire. So here they given initially R1 is how much now? 160 ohms. R2 equal to we need to calculate. Right. So this is L1 which I call it as L. L2 is what tell me now? This is L by 4. 1/4 of the new length. 1/4 of the length. So we can write as what tell me now? R1 by R2 which is equal to L1 by L2 whole square. So this R1 is 160 by R2 and which is equal to L by this is L by 4 whole square. Simplify now here 160 by R2 and which is equal to 4 square 16. And simplify this thing, how much will come? So this is R2 will come to be a what tell me now? 160 by 16. 16 na? So that is R2 value will becomes 10 ohms. Yes, good evening. Next one. The current flowing through a conductor connected across 2 ohm resistor, 2 ampere is 1 point across a source is 2 amperes and 1.2 amperes at 0 degrees and 100 degrees Celsius. The current flowing through the conductor at 50 degrees is. So indirectly they are asking the resistance calculations only. So what is the resistance now? Tell me now, which is equal to V by R. So the source is say V by I. So this means, so this is R1 equal to what we can say now V by 2. And this is at 0 degrees Celsius. At T is equal to 0 degrees Celsius. Next, what it is R2 value? V by 1.2. This is at where? At T is equal to 100 degrees Celsius. The current flowing through the conductor at 50 degrees they ask him to find. At 50 degrees. So the variation of resistance which will be given as R, that is R is equal to, that is R naught into 1 plus alpha T. R naught into 1 plus alpha into T. So initial resistance R naught they given V by 2 now. That is V by 1.2, which is equal to V by 2 into 1 plus alpha into temperature is 100. Next, we need to find this one. So this is V by, this will have some current. This will have some current. This current, let us say I if I call, which is equal to V by 2 into 1 plus alpha into 50. Okay. Alpha required. Alpha required. Now without that we cannot do it. Now let's get the alpha from this first. Alpha value required now here. So this value if we cancel now here, this value 0.6. So that means we have 1 plus 100 alpha, and which will be equal to, we can say now 10 by 6. That is 100 alpha, and 10 by 6 means 5 by 3 now. Will becomes what will be now 2 by 3. So this alpha value, yes, 2 by 3 into 10 power minus 3. This value we use the second equations to get the value I V by I, which is equal to, this is V by 2 into 1 plus alpha, that is 2 by 3, 10 power minus 2 or plus minus 3, minus 2. 10 power minus 2 into 100. Simplify now here, this will get cancelled now, 2 zeros, 2 zeros. So this VV will get cancelled. We need I value required. So that is 1 by I, which is equal to 1 by 2 into 5 by 3. So then I value which will come to be a 6 by 5. 6 by 5. So 6 by 5 means what will be now? 1.2 now? 1.2. And they are asking in terms of milli. So what we can do here, this is, yeah, so this is milli, 12. 12 into 10 squared milli I can say now, tell me. 12 into 10 squared, yes. So this value which is equal to 12. Yes, 12 into 10 squared milliamperes. What we got? 15 you got. Check it, 12 or 15. Next one. The length of a metallic wire is increased by 20% and its area of cross section reduced by 4%. The percentage change in the resistance is, okay, so this means they given the length is increased now. L2 equal to 20% increase. That means we can say, if I call L1 is equal to, let us say L1 is equal to 100 if I have taken, L2 is 20% increased means it is 120. And area decreased by 4%. Initially area if I call it as 100, and this area decreased now, that is 96. Now tell me now how this variation of resistance, that is R proportional to L by A and rho is constant. So we can write it as R1 by R2 and which is equal to L1 by L2 into A2 by A1. So how much will come? R1 by R2 which is equal to L1 by L2, that is 100 by 120, A2 that is 96 by 100. So this will get cancelled now. 4 3 zeros now here. 4 twos and 4 fours. And again 250 and 212. Threes will cancel now. 3 fours, 3 fives. So this is R1 by R2, which we have it as a 4 by 5. And that means R2 by R1, which is equal to 5 by 4. So this is subtract 1 both sides, and which is equal to 5 by 4 minus 1. Then R2 minus R1 by R1 into 100, which is equal to 1. 1 by 4 into 100. So this value equal to how much now? 25%. Next one. The charge flowing in a conductor changes the time as given as like this. The minimum value of current is they given the charge given Q, that is alpha T minus beta T square plus gamma TQ. So how we can get this current to tell me now? I is equal to basically dq by dt now. By differentiate the charge will come the I. So how much is I value tell me now? Alpha minus 2 beta T plus 3 gamma T square. This we got my current we got. This is the current we got now. Yeah, so now see what they're asking here. This current they are saying it as a minimum. How we can find the minimum value of any function? Will differentiate, will equate it to 0. How to find the maximum, minimum of any function? This is the function in time. We need to identify minimum value. Okay, for the minimum value, so we should equate the f dash x equated to 0. So this means f dash means here I dash na. I dash is how much? 0 minus 2 beta plus 6 gamma t, and the f dash x equated to 0. Then equated to 0, so it will becomes as what? Tell me now here, 6 gamma t, and which is equal to 2 beta. Then t is equal to what we have? Tell me now, 2 beta by 6 gamma. So how much will come here? Beta by 3 gamma. This is t we got. And we'll substitute this value in the function now. Yes, now. So the minimum value, which will be equal to, we can replace t value here. This is alpha minus 2 beta into t. T means how much? Beta by 3 gamma. Yes, plus 3 gamma into t square. That is beta t square by 9 gamma square. Yeah, simplify this thing here. Now, so this is 2 beta square by gamma plus 3 threes, and this gamma, that is what I'll know, beta square by 3 gamma. So this will come to be alpha minus, okay, here 3 ways 3, here 3 is there now, okay. So it will come to be a beta square by 3 gamma. Check this thing. This is the minimum value of current. Alpha minus beta square by 3 gamma. Next, the resistance of a wire is 5 ohms. Okay. Its new resistance in ohms if stretched to 5 times to its original length. The resistance of a wire is 5 ohms. Okay, initially. Its new resistance if stretched to 5 times the original length. Right. So initially resistance are given as a 5 and we need to find this R2 value. For what you tell me now? Initial length if I call L and final length is what? Tell me now here 5 times the L. Right. So that means what I can say now, R proportional to L square. That is what I'll get. Tell me now, R1 by R2 which is equal to L1 by L2 whole square. Now this R1 is 5 by R2 equal to, this is L by 5L whole square. Yeah, simplify now here 5 by R2 and which is equal to 1 by 25. That is R2 equal to what? Tell me now. 125 ohms. Next, if a copper wire is stretched to increase its length by 20%, the percentage increase in resistance of the wire is. So this means, yeah. So if I call this as length, so L1 which is equal to initial length we have taken as 100. So L2 is how much now? 120. Okay. Now this R proportional to L square. R1 by R2 which is L1 by L2 whole square. So that means R1 by R2 which is equal to 100 by 120 whole square. So 0, 0, 2, 5 and this is 6. Now, so what is this R1 by R2 will come to be a what? Tell me. 5 by 6 na whole square. 25 by 36. Isn't it? So that means we'll find R2 by R1 which is equal to 36 by 25. Subtract 1 both sides. R2 by R1 minus 1 equal to 36 by 25 minus 1. That is R2 minus R1 by R1 equal to 36 minus 25 by 25. So again multiply with the 100. R2 minus R1 into 100 and which is equal to 11 by 25 into 100. 25 fours which will come to be a what? Tell me now? 44%. Next one. A 1 meter long wire is broken into two unequal parts, X and Y. The X part of the wire is stretched into another wire, W. The length of W is twice the length of X, and resistance of W is twice of Y. Then find the ratio of length of X and Y. Understood the problem first of all. So here I have 1 meter long wire is broken into two unequal parts, X and Y. So this is one part, this is another part. This is a X, this is a Y I'm calling. This length is L1 and this length is L2. The X part of the wire is stretched into another wire, X wire, which is stretched to another wire, W. Now this wire is W. Length of W, so this is this length, if I call it as L3, which is equal to twice 2 times of X. So this is 2 times of L1. Okay, next. And resistance of W and this Y will be remain same only. So this length is L2. And the resistance of W they given as what? Tell me now. 2 times the resistance of Y. Okay, resistance of W is 2 times. So you can tell me now here resistance. How the resistance proportional to L square, stretching na L square proportional na, and they given this as resistance of W, they given as a 2 times of resistance of Y. And so this is, I can say now RW equal to 4 into RY, I can say now, since it is stretched. So what is the resistance of this? Yes, length of this is W given at 2 times. So what I can say now here, the length of W, which is equal to 2 times the length of X now. That means the resistance of W, which is equal to 4 times of resistance of X. So that is 4 into Rx, which is equal to 2 into Ry now. So that is 2Rx equal to Ry. So that is 2 into Rx is equal to, that is rho Lx by A. So same wire now. And this rho Ly by A. Simplify and get it. This is Lx Y. This is W Y we have taken. So check for cancellation now. Rho cancel, A cancel. So that means Lx by Ly, which is equal to 1 by 2. Option D. Badhiya, badhiya, badhiya problem. Next. A wire of resistance R1 is drawn out so that its length is increased by twice of its original length. The ratio of new resistance to original resistance is, the ratio of new resistance to original resistance is, a wire of resistance R1 is drawn out so that its length is, that is length increased by twice the original length. So that means R proportional to increased by. Okay. So here you need to understand what they given now here. So it is increased by twice. Initial length is L, so it is increased by 2L1 now. So total it is 3L1. R proportional to L square, so that means R2 by R1, which is equal to 9 by 1. Here the condition is they mentioned that it is increased by twice, 2 times. Originally is L1, it is increased by 2L1. So total length will becomes what, tell me? 3L1. Next, the variation of applied potential and current flowing through the given wire is shown in figure. The length of the wire is 31.4 centimeters. Diameter of the wire is given. The resistivity of the wire measured is. Yeah, here you see this thing. This the graph is straight line. So as we know, slope of the line, slope of this voltage and current graph is nothing but resistance only now. That is V by I. That slope is nothing but tan theta. So from this, what I can say now, resistance is equal tan 45, that is 1 ohm. Indirectly, they given resistance as 1 ohm. What the resistance formula? R is given as rho L by A. So this is equal to 1. So we need to find the rho value, we need to calculate. So which is equal to A by L. A value how much? That is pi R square. R is 1.2 into 10 power minus 2 whole square by length is 31.4 into 10 power minus 2. So how much is value? Okay, so this pi into what I can say 1. So here 12 into 10 power minus 6 by this I can write as 1 point we adjust now here 3.14 into 10 power minus 1. So this value will get cancelled pi. It is 144, right? So this rho value 144 into 10 power minus 5. This value which will be given as 144 into 10 power minus 3 into ohm centimeters. So this x value we can say it as 144. Next one. The resistance of the wire is measured as at 2 and 3 at 10 and 30 respectively. Temperature coefficient of the resistance. The variation of resistance we have seen now here. So that is R is equal to, that is R naught into 1 plus alpha T. S2 is equal to, that is R naught into 1 plus 10 into 10 alpha. 10 alpha. Next, which is 3 is equal to R naught into 1 plus 30 alpha. So take the ratio between these two here, 3 by 2, which is equal to 1 plus 30 alpha by 1 plus 10 alpha. Simplify now, we have 3 plus what will be now 30 alpha, which is equal to 2 plus 60 alpha. 1 equal to 30 alpha, then alpha is equal to 1 by 30, which is equal to 0.0333 degrees Celsius. Next, the current density in a cylindrical wire of radius they given 4 mm is given. The current through the outer portion of the wire between the radial distance R by 2 to R is. Okay. R by 2 to R they are asking to find. So basically this current is given I in the complete cross section 4 into 10 power minus 6 ampere per meter square. Yes, this is my conductor having this radius which will be equal to capital R. They asking the current where here R by 2 to R. Okay, so they asking the current in this region only they asking. Yes, in this part only they asking, not this part. So here only the shaded part only we need the current. R by 2 to R. So what I need to do here, tell me now. What I will do here? So R by 2, this part of current only we need. First we will get the current density J, which is equal to what tell me now here, 4 into 10 power 6 by pi R squared now. So we need the current from where to where now here to here only. In this region only we need the current. So then what I do here, this I, so required current Ix if I say, and the total part of current minus that part we need to do it now. Or we can say this is J into this part of area now here. This area is what tell me now total area, that is pi R square minus pi into R by 2, that is what an R square by 4. Check this thing all of you. So this means Ix which will be equal to J into, that is 3 by 4 into pi R square. Okay. So how much is value of Ix now? J, that is 4 into 10 power 6 by pi R square into 3 by 4 into pi R square. So simplify now here, pi R square 4, 4. Then this Ix value will come to be a 3 into 10 power 6. What here? But option to nahi na. Okay, they given current density only given, yeah. Sorry. Whatever they given, that is current density only, isn't it? So again, we no need to divide it. That's a mistake we did. Current density only they given directly. Again, no need to divide. The given thing is current density only, na. So that is 4 into 10 power 6 J value. This is not I. They given directly J only given current density. So this value 3 by 4 pi R square. Yeah, now tell me this thing. So this current 4 cancel. So that is 3 pi into 10 power 6 R square. Radius is given as 4 mm. So that is 4 into 10 power minus 3 whole square. So this Ix value, so 3 pi into 10 power 6 into 16 into 10 power minus 6 will get cancelled. So this Ix value 48 pi. Okay. Next one. Yeah, this is also same problem, I think. So the current density in a cylindrical region is given 4 mm. Same thing, isn't it? Same problem. Okay, the value densities differ. That's all. The current through the outer portion, exactly same problem. Here, this is, here, tell me now here, Ix, which will be equal to J into what I can say now here, pi r square minus, yeah, so this is pi r square by 4, right? So how much will come here? This is J into 3 by 4 pi r square. So how much is Ix value? J value, that is 1 into 10 power 6. That is 3 by 4 pi into r square. R is, yes, that is 16 into 10 power minus 6. Will get cancelled 4 fours. Then how much is value of Ix now here? 12 pi. La, 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 la. Yes, an aluminum wire is stretched to make its length is how much they given now? 0.4. This is less than 5%. We can do normal formula. R proportional to L square. So that is delta R by R into 100, which is equal to into delta L by L into 100. So this value 2 into delta L by L is 0.4, which will come to be a 0.8%. Next, the length of a given cylindrical wire is increased to double of its original length. The percentage increase in the resistance of the wire is, percentage increase the resistance of the wire. Length is doubled. So this is L2 is equal to 2 times of L1. So R proportional to L square now. That is R2 by R1, which is equal to L2 by L1 whole square. So that is R2 by R1 minus 1. So that is L2 is a 2L1 by L1 whole square minus 1. That is R2 minus R1 by R1, which is equal to 2 square. 4 minus 1, 3. And percentage now, that is R2 minus R1 by R1 into 100, which is equal to what? Now 3 into 100 now. So that is 300%. Okay. Fine. Yeah. Okay then. Yeah, that's it for today's class, and we'll meet in the next class. With this today's, now you'll understand this thing, variety of resistance problems we did. Like this, we'll continue the same manner, we'll continue in the next class. Tomorrow, the same timing we'll do. Okay then, see you. Bye-bye.